quadratics, we are in fact talking about what we call vertical motion, right? Something is going up, something is coming down, or something is coming down and then going back up. And there is usually an equation we can write for that. So we saw at the very beginning of this unit, we watched a little video, there are lots and lots of quadratics in the real world. We also, before our quiz, we talked about what are we looking for. So if they ask us a particular question, do we know what we need to find? So today we're going to take all of those things and we're going to put them into motion. So our first example here, we're going to do a little bit of I do, you do, we do kind of thing. The path of the ball kicked upwards, and I have several soccer people in here, so I don't think you look quite like that, but she's probably cuter than you. H is equal to 35t minus 5t squared. Now, I do want you to notice that even though these are written in a different order, the negative 5 is actually our A, because it's with the t squared. Do you see that? So this is actually our A, and this is actually our B, right? Because we know that in standard form, we have y equals ax squared plus bx plus c. So even though it's written in an opposite order, that's okay. This is still our A. H is the height of the ball in meters, and T is time in seconds. So before we do anything, what can you tell me about what this graph might look like before we put it in the calculator? Based on what we've learned about A and C. What do you think? Narrow and opens down. I like that. All right, so let's go to our calculator. And we're going to go to number 2 graph. And we're going to just, now, I know this says t, but we're going to use x because in our calculator we have f of x. Now, if we went in and we changed this to f of t, then we could use t, but that's a whole complicated thing, so we'll just use x. It just makes life easier. 5x squared. Does everybody have that in there? And we can see here, oh, well, it is fairly narrow. Like you said, it does, I guess it opens down. We're not sure. How do we change this so we can see it? Menu what? 4A. All right, there we go. Now remember, this graph is purely for the function. This is not for the situation. And since we are in fact talking about meters and seconds, we will only be looking at quadrant 1. All right, and we can use the information from this to answer these questions. How high is the ball after 3 seconds? Well, how would we figure that out? We have a couple of strategies. What is 3 seconds representing? This is representing x. So could we in fact say h equals 35 times 3 minus 5 times 3 squared? Could we put that into our calculator? We could. All right, I'm going to add a doc. If you remember Control Doc, we can go calculator. We can put that in, 35 times 3 minus 5 times, I'm just going to do 9 because 3 squared is 9, and I get 60. So we would say the height is 60 meters at 3 seconds. Is there another way we could do this? What are you thinking? Yeah, we could go back to our graph. We've already put it in. And we could say Control T, time in seconds is 3. Look right there, 60. So we did do it correct. So your other option is Control T, x equals 3, and we can see that y equals 60. All right, so not difficult. Now you do have to make sure you know what you're looking for there. What about letter B? When will the ball be 50 meters high or higher? Huh? At what? 2 seconds to 5 seconds right here. How do we show 2 seconds to 5 seconds? And again, I'm just going to make a little note that we're looking at the table here. Yes. 2 is, we can write it like a what? Is this a domain or a range? This is a range. So 2 is less than or equal to, what are we using for, or we want to use y, or you could use h, either way. Or is it, but is it, it says when. It's t, it's x. This is height, look right here, height. We're talking about when, which is t. So we could use t, or you could use x is less than or equal to what? What did we say? 5. So that means from 2 to 5 seconds continuously, that ball is at 15 meters or higher. Okay? And we are using the or equal to because it at 2 and 5, it is at exactly 50. Okay? When, so again, this is an x. When does the ball hit the ground? What are we looking for there? This is a 0. Give me another word. A root. What else? X-intercept. Solution. Very nice. When? How are we going to figure that out? We can look at our table. And what does the table tell us? The ball hits the ground at 7 seconds. Okay, is there another way we could do this? I like that. We could definitely use the table. Can I make the table go away and maybe, what do we are looking for a root, right? That's what you told me? What else could we do? Do you remember? We can look at our graph. We could count it, or we can do menu. Do you remember the keystrokes? 6, 1. Very nice. And we're not worried about this one over here. We're just worried about this one. And you can see right there, 7, 0. So that's your other option. We feeling okay so far? At what height was the ball kicked? And does this make sense? What are we looking for here? At what height was it kicked? Oh, very nice. So this is the y-intercept. What is our y-intercept? It happens to be 0, 0. So at what height? So the ball was kicked. At 0, we're talking about meters, right? 0 meters high. Does this make sense? Yes, because where is the ball? The ball is on the ground. All right, how do we feel about these word problems? All right, we're going to do the second one. The second one is talking about an archer. They shoot an arrow into the air. The equation that describes the path of the arrow. Again, notice this is backwards. Usually when A is negative, they like to put it at the end. I don't know why. But this is our A, this is our B, and this is our C. Where H is the height in meters and T is the time in seconds. What do you already know about this graph? Yep. Oh, okay. So we have a y-intercept of 0, 5. What else do we know? It opens down. What else do we know? Narrow or wide? It is narrow. So what I'm going to ask, this is going to be a we do, right? As in we at your table. I would like you to work and come up with these 4 answers, and then we'll come back together, and then this last one is going to be a you do on your own. So take a few moments here and see what you get. So now that you've had some time to work at your table, let's discuss how high is the arrow after 2 seconds. Again, that is your X. So you could plug it in and use your calculator. You can see I did that here. 19 meters, or you could do Control T and look for where X is 2. You get Y is 19. So a couple of different ways for you to be able to do that. What is the max height of the arrow? That is a max vertex. You can use your menu 6.3 with that dotted line on the calculator. You get 1.7 and 19.5. So the max height is 19.5 meters. And then C says, when does this occur? At 1.7 seconds. So you can actually answer 2 questions from that. When, so that's it, that's an x value, that's a seconds, will it come back to the ground? So that's a root, x-intercept, solution, or a 0. You can use menu 6.1. Because if you're looking at the table, it's only going to have whole numbers, and these are not very pretty. 3.670, so the arrow hits the ground at 3.67 seconds. How did you do there? Very nice. Okay, so take a moment now. Let's talk about the baseball. Baseball is hit in the air. The path of the ball is described by the equation. Again, don't get mixed up because it's written backwards. H is height in meters, still time in seconds. So I would like, this is a you do, this is a on your own. Take a few minutes and finish this, and then we'll discuss. All right, so you should have gotten, when you did this one, 28.5 meters at 3 seconds. Again, you can use the calculator or the table. The max height, so again, that's menu 6.3, 2.3 and 31, so 31 meters is the max height. When does it get there? At 2.3 seconds. This one, oh, I'm sorry, I misread that one. Thank you. I apologize, I was not reading well. At what height was the ball hit? So that is your C value, right? So 4.5 meters high. Thank you. And that is actually our y-intercept. Sorry, I misread that when I was looking over here. Thank you for that. And when will it be at 115? You can look at your table and look for 115, but we know that if the max height is 31, it's never going to get to 115. All right? Questions? All right, we're going to do a little bit of practice. It's not super long, and we'll go over it tomorrow. Okay, there is a third page on Classroom. It's this one. We're going to do this one tomorrow, so don't worry about that if you're looking at Classroom, okay? So let's see what we can do.